Let's look at final exam question number 54 in Electronics Demystified 2nd edition. If you have the printed book, please see page 428. And also, please look at the previous questions video, question number 53, because it involves the very same type of circuit as we have here, a resistance inductance circuit where the resistor and the inductor are in series with each other. We can plot situations like that on a quarter plane graph with resistance on the horizontal axis in real number values and inductive reactance going up on a vertical axis in imaginary number values. That's what this J operator is all about. What we're looking at here is figure 3-9. If you have the printed book, you'll be able to find it on page 76. It's back in chapter 3, of course, where we discuss the way that resistances and inductances in series combine. In the previous question, we learned how the phase angle, that is, the extent to which the current lags the voltage. Remember, in an inductance, in a circuit with inductance and resistance in series, the current lags the voltage. It can lag that voltage by anything from near 0 degrees. If we have, for example, a certain amount of resistance and only a very small amount of inductive reactance, the phase angle is very small, the angle of lag is very small, near 0. It can increase as the ratio of inductive reactance to resistance increases, and depending on what the actual values are, we'll get vectors that look like this, and they will gradually approach this vertical axis. In fact, if the reactance, imaginary inductive reactance, is many, many times the resistance, thousands of times, then we'll get an angle of lag just about 90 degrees, and we'll get just about a vector that goes just about up along this vertical axis, like, well, almost there, like that. Okay? But this question is asking us what happens if the inductive reactance is only a very tiny fraction of the resistance. So in that case, we get points down in this part of the plane near the resistance axis, and the angle of lag is very small. So the current and the voltage are almost in phase with each other, and the correct choice, therefore, is A.